Hey guys, what's going on? Today I'm going to be showing you how to use this new 1.5 inch OLED screen that I picked up. This is a 128 by 128 pixel 1.5 inch from diagonal to diagonal OLED screen. And today I'll be showing you how to hook this up and interface it with a microcontroller and then display a small RGB image using a bitmap not loaded from an SD card, and that's using it within the built-in program memory. So this screen is pretty cool. It has capabilities to display RGB colors, so any color that you can think of, and you can take any image offline and be able to display it on this screen. So I'm only displaying images on this one half of the screen, but you can just display images on this entire 1.5 inch screen. To note here, it looks like on the camera that it's flashing a little bit, but in person you can't see any of that flashing, and it looks really nice. The benefits of this OLED is the colors look really nice because the black is a true black in OLED screens, and when there's no color being displayed, the pixels are off. And it takes a very minimal amount of power to run these screens. I'll link the products in the description below. This screen cost me about $28. I have a couple of versions I got off of Amazon. This version, I don't know the brand exactly, but it costs $28.99. I'll link it down below. And then I have another one coming from Waveshare that's also the same, but slightly a different board that it's mounted to, and it costs roughly the same price. So this SSD1351 screen interfaces with a microcontroller via SPI, and you can use 4-wire SPI or 3-wire SPI. So in order to hook it up, on this screen at least, the first pin here is the ground pin, and that goes to the ground pin on the Arduino. The second pin is the VCC pin, and that's for power, and you hook that up to the 5-volt on the Arduino. And this SCL, I think, is mislabeled, but that's the clock data pin. And then this SDA pin, I believe, is the data input pin. And then RES, that's the reset pin. DC, that's the data command selection pin. And then CS is the chip select pin. And so these first two, ground and VCC, go to ground and VCC on the Arduino. And then from the SCL pin all the way to the CS pin, those can be programmed using your Arduino IDE to be whatever digital pin you want it to be. Another one of the benefits of these OLED screens is the wide viewing angle. So if I turn the screen like this, you can see that image pretty much at a 90-degree angle, and from whatever angle you're looking at it. Compared to an LCD screen, you would not be able to do that with an LCD screen. So these OLED screens are pretty versatile in the fact that you can use them in pretty much any environment. I haven't tested them so much outside in the sunlight environment, but it's a relatively good brightness on these screens, so they're pretty easy to see, at least indoors. We'll have to do some more testing outdoors and see what it looks like under sunlight. Okay, so here's the product on Amazon. This one's sold by Vicky, and then this other model is sold by Waveshare. Waveshare also sells a bunch of different other kinds and sizes of OLEDs, but I got the 1.5 inch RGB, and I'll link these in the description box below. Okay, so now I'm going to run through the process of finding an image and then being able to display that image onto the screen. So first you're going to want to come to this site. You can go to any site that you want, but this site seems to have a lot of icons. It's called icons8.com, and then you can come in here and search for whatever image that you want. So I'm just going to come up here and click on icons and type in, let's say, smiley face. So I'll find a smiley face that I want to draw. This one looks good. And the key here is we're going to want to find an image that's relatively small, and you can go up to 128 by 128, but keep in mind that the bigger image that you have, the larger file size it's going to take up and store into your program memory when you convert the image into a bitmap. So the larger image that you have, you're going to need more memory. So the capacity on this Arduino Uno is about 30,000 bytes, and an image that's relatively 50 pixels is probably going to take up around 3,000 or so bytes. So I'm going to take this image, I'm going to download it. I'll call it Smiley, and it was 48 pixels by 48 pixels. So I'll call it Smiley 48. Okay, now that you've downloaded the photo, you're going to want to come to this website where you're going to be converting it to a bitmap file. So it's rinkydinkelectronics.com. I'll put that in the description box below. But you go over to your file, open it up into this website, and then it can convert that file to a bitmap for you. And then you're going to re-download it and save it. And then once it's done, you can open it up in Notepad, and then this is the bitmap file that you can copy over into the Arduino IDE. So I'll show you how to do that. Okay, so you're going to take that bitmap file from your Notepad and then copy it into a new tab in the Arduino IDE. So I have a current file open with the exact same setup. I just copied in the new bitmap file into this new tab, and I'm going to rename this tab that same file name. So in this case it was Smiley48. I'm going to rename it Smiley48.c. I'll save that, and then I'll come over here and include that same file. It's called Smiley48. So just running through this whole code here, you include the SPI library that allows you to use SPI for communication to the display, and then you include this gfx.h. That's the basic graphics library that you can use for different graphics interfaces. I don't know if you necessarily need it for this code, but it's good to use for OLED screens. And then this is the hardware specific library for the SSD1351. That's this screen. And then I'm going to be including that .c file into this code. These are the dimensions of the screen, 128 by 128 pixels. And then down here we're defining the pins. And then here's a basic definition of all the colors that you can reference in your code if you want to make a quick reference to a certain color instead of using the specific number. So this initiates the display using your screen width and height, and then the communication pins that you want to use. And then in your setup you use display.begin, and that initializes the screen. And then just in case you have anything else on the screen before, you fill the screen with black, and that'll get rid of anything on the screen. And then going into your loop, you use display.draw RGB bitmap, and that's important if you want to have any images that you reference from a bitmap file that's included in your program memory to be in color, like an RGB color. So these two first numbers here, they are the position in X and then Y, and then I'll change this over to Smiley48. That references the name convention that you used for the file, for the bitmap file. And then these numbers here, should change that to 48. It was 48, right? Yeah, 48 pixels by 48 pixels, so that's 48 wide and 48 high pixels. And then this is just going to loop over, since I'm not changing location or anything, I don't necessarily need the delay. But this should in theory show up on the screen at position 0, 0, the size of 48 pixel by 48 pixel smiley face in color. So let's test that out. All right, and just flipping back over to the OLED on the Arduino here. First shot and it worked, woohoo. So we got the 48 pixel by 48 pixel smiley face. Again, that flashing is just the camera and the refresh rate on the screen not working out well. So here in person, there's no like refreshing that it looks like on the camera, but on the camera it's showing an issue. So there we go. That shows how we can display some RGB image on any location. So for example, let's change this in the code real quick. If I want to bring this over to position 30 and 30, and then I'll re-upload it. So the smiley face should now move in 30 and 30 with the same image. So it's just uploading, and there we go. So it moved over to position 30 and 30 for the same image. So hopefully this helps if you want to include some sort of small RGB image into your projects, and it's an easy way to use it without an SD card. There are other methods where you can use bigger file sizes on SD cards, but this is a basic way to implement small images into your project. Let's say if you're using a sensor and want to display a value and show a small image next to it. So thanks for watching. Hope this helps, and stay tuned for more videos in the future. Cheers.